All right, let's jump into this blog though, because we were talking about ECR. It's funny, I keep trying to like scroll my screen and close tabs by clicking on the stream instead of down here where I'm sharing my screen. So
That's
today's just not going to
yeah.
be a good day for me. I hope this show actually works out.
Brent, can I just jump in quick? I just want to clarify with Denny1111. I was just joking about FERPA. I don't think we're actually violating anything saying Zach's name. So I just wanted to clarify. We don't actually have a problem.
Luckily, he has
And look,
also,
yeah,
he
all
said,
good, all good.
I'm
So there's
just going to
proof.
recommend when you start this show
right.
on YouTube, start 20 minutes in. Just start at the 20-minute mark. Anyway.
Okay. Serious. Here we go. All right. Oh, wow. Okay. And I thought we weren't going to have anything to talk about. Okay. So what we wanted to talk about in this show was multi-architecture container images. And I always start out, why? Like, who wants to do this? What's the big deal with being able to have a multi-arch container? And by the way, do you say multi-arch or multi-arc? Let's figure that out.
So I'll say, since I wrote this blog, I never really use multi-architecture container images, that term. I always just talk about manifest lists. And I think anybody who had sort of monitored this problem and watched us as a community find a solution, I think also thinks that first. And with the OCI image spec, that's actually called an image index. But really what with the term multi-architecture container image, what we're really talking about is like the customer need. You don't care that there's a manifest in there unless you have to author one, right? Oh,
right.
Denny clarified joking. Okay, cool. All joking. Good. So yeah, like, what are you trying to do with this? What problem are we solving? And really, if you think back, 3-4 years ago, or actually more recently, if you're on ECR, if you have an image that needs to run on both, an ARM processor as well as x86 based processors, how do you do that? You've got, say you've got a little bit of Go code and a microservice, and you're going to build it up, and you're going to build it for an architecture.
Right.
How do you know which one you're deploying to your ARM nodes versus your x86 nodes?
Well,
and there's a lot of different ways to do that. Sorry, go ahead, Brent.
Yeah, no, you're absolutely right. But let's just back up a half step and just point out the fact that we're so used to thinking about and we even say it a lot. We say containers, they can run anywhere. But there are still a couple of limitations to that. And one is that if I build an x86 container, I can't go run it on an ARM processor unless perhaps it's an interpreted language or something like that. But for the most part, I need to be specific with specifying the architecture. So I need to build.
But even with an interpreted language, say Python, you need the right binary in place on the right architecture to create the bytecode and actually run your app. Really, it is a problem, and was a problem sort of from the very beginning. Not a problem with containers, right? This is just a software thing. You're going to take some code and you're going to create a binary. It's got a couple of things: operating system and ISA, right? Instruction set architecture. Those are pretty critical. It's not only architecture. Maybe you've got some code in Rust or Go or C, C++, whatever. Maybe you're going to make a system call. Well, you're going to make sure that system call is there, right? Even with Unix, right? All the different flavors of Unix, you got different syscall implementation. Some of them have different arguments. So really, you got to say, what am I building this for and where am I running it?
Right.
Now, the cool thing about containers is it lets you say, okay, well, here's my software. Let's push it all in there with all its dependencies and now go run it.
Right.
Well, the go run it part needs to say, go run it on x86 or go run it on ARM or go run it where Windows lives, right?
Right.
And so that's where you get into this need for not only defining the architecture and the OS, but also being able to tell a client, hey, this image, by the way, if you go back up to the top, actually, the first diagram here, this is actually what an image looks like under the covers. And you have this thing in the image manifest. The manifest is the thing you're going to talk to first. And that's just some metadata. and it will have the ID, and inside of it, it has a config. So you can see in config, architecture and OS are there. So fine, we have a way to say, oh, this is a Windows for x86. This is a Linux for x86, right? So we can say that. Now, how do you know how to pull that? Well, you'd use something like tags, or even the repo name. So you'd say,
That's right.
okay, my app dash x86 dash Windows, or maybe a tag, my app tagged x86 Windows 2.5, right?
Exactly. And let me show that to you, because you have a really good example built here. So we'll just start out. We'll start out there. So I've cloned your repo. I've set the, let me make sure that this is set actually. Okay, and just for good measure. Okay, cool. So I've set my account ID and region, and then I've cloned your repo, and then you put a make file in your repo, which is awesome. But let's just take a look at what the make file is doing.
I love make. Don't you love make?
I love make. It's awesome.
Mm-hmm.
So we have AMD 64 and ARM 64 as targets, and we're doing a Docker build, and we're setting build arg and go arch. And we're specifying for AMD 64, go arch of AMD 64, and ARM 64, go arch of ARM 64.
So that first one is 64-bit x86 architecture, and the second one is 64-bit ARM architecture.
Exactly. So what we're doing here is kind of the old school in Docker timeline. The old school way that people had to manage this stuff is they would build two separate images and they would tag them differently. So if we do make all, what I'm doing right now is I'm building first the AMD 64, the Intel based image, and then the second build that'll happen will be the ARM 64 image. So once I have those two images, I would have to either, like you were saying, push them to two separate repos, or I would have to tag them differently and push them with differing tags to be able to differentiate between these two architectures.
Exactly right. And that's what we did for quite a while. And as so many other things in this entire container ecosystem, out of that sort of pain rose the necessity to address it. And so you had this work that was done at Docker and by a number of open source contributors and people at different companies and in the community, where we came up with this idea to address this problem, which is the manifest list.
Totally.
So if you actually, right there, if you go back to your terminal and just, what'd you call that image? Hello. So we have hello and tags, right? So do a Docker manifest inspect on one of those.
Manifest inspect?
Inspect manifest, inspect, something like that.
I
actually haven't used that in a long time because I always use manifest tool, but if this doesn't work, we'll just move on. But I'm just trying to make a point. Okay, yeah, it's not going to work. So that's fine.
What about just Docker inspect?
Yeah, you can inspect the image. Yeah, of course. There you go. See, like I said, I always use manifest tool, so I kind of like forgot what I was doing. So in here, you have basically a lot of the elements of, now this is the Docker implementation of like what's on disk, but in here you have all of the different aspects of the image you just built, including like the command run and all that. But we have a config block, and we have the OS, the architecture, everything's in here that you need. So as long as your client can identify this in a registry somewhere, it can pull it and you'll get the right bits. That's all I wanted to make clear. So
right. Well, so then so then what's the big change with ECR then that makes this situation better? Why can we get away now with not having ARM 64 and AMD 64 tags?
So as I think, or I hope the blog makes clear, this isn't so much an ECR innovation as ECR enabling it for our users, our customers. So basically this work that came along called the manifest list allows you to, if you go back up to the top, I think I have a little bit of art there that'll show this just because I like diagrams. So up above this one, you have what we were talking about before, which is the image manifest. Now, when you package up an image and send it off to a registry, or when you pull an image from a registry, this is what it's working with, this image manifest, which we were talking about before. Now, if you go down a little bit to the next drawing, you see now we have this new manifest list thing. And this is, 3-4 years, at this point, but so it's not new. But the thing that was introduced to address the need to tag architecture, OS specific things is this thing called the manifest list. So now what you have are, this top level manifest, which is a list of other manifests. Okay. So in this case, you see there's Linux AMD 64, which points up to an image manifest itself that defines the actual image that you pull. So what this allows your client to do is to say, just Docker pull hello, or hello version, or hello git commit ID, and not a hello with the OS and the architecture and stuff. And then the client will sort of figure it out from there. It says, well, I am Linux, I am ARM, 64, I am AMD 64. I'm going to go pull the right stuff, get you the right. Now we could talk a little bit about how the containers work, but I would imagine most people know that, right? Because once you get here, you're basically going to explode all your file system layers, set up a container, your runtime takes over, and off you go to the races.
Exactly.
So that's really the elegance here.
Exactly. And what this helps us do is think about it from in terms of like setting up your orchestrator. At the orchestrator level, I might want to deploy this hello world, this YAHW, as you named it. I might want to deploy this across a fleet of instances, and those instances might be mixed. Some might be Intel-based, some might be ARM-based, and I don't want to have a custom deployment for each of those, right? So I can actually have one deployment and then mix, my instance types, maybe based on spot pricing for the day, or maybe based on just available capacity, or what kind of RIs that I happen to have, purchased that I'm not using. Just there's all kinds of decisions that might play into what does my pool of resources look like. And I don't want to necessarily have to scale independently each of those types of architectures. I want to be able to just think of them as just a big pool of compute and have Docker pull the right image based on the underlying architecture. So now I can tag things back to the way I was doing it when I was only on one architecture, which was image name, maybe version number, or latest, or something like that. So that's
and as
really,
we all know, it should never be latest, right?
That's right. That's right.
Okay.
That's right.
Don't use latest, y'all.
So
but yeah, exactly. So it gets you to this nice workflow where you can use, a deployment method. You don't have to have this OS or architecture specific stuff. It's great.
Exactly.
So there is a question.
Oh yeah, go for it.
There. Well, hopefully we answered the first one, which is what's the big change here? So the big change is that ECR supports manifest lists now, so you can do this with ECR at scale, securely across your whole enterprise. So
exactly.
Can I store VMware image? Well, so it's interesting. There are a number of registry implementations out there. Some of them are open source projects. Some of them are proprietary commercial products. It's possible to do that. But what you're talking about with the VMware images, somebody remind me, VMDK, VMI, those images. So those are.
It's been a while. It's been too long.
Yeah, so it's like the diagram we looked up at top, but it's a totally different beast. It's actually, I think it uses those use XML metadata descriptors, and they use the open disk standard, and so it's a very different beast. Technically, it would not be a violation of the distribution spec, I don't think, if you wanted to do that, but it would be pretty difficult to manage. And because of how most of the registries are implemented, there's a lot of implicit decisions, so it probably wouldn't work.
Should we just say specifically for ECR not supported?
And I was going to end by specifically for ECR, no.
Nice. And he does have, John have one other question. Why can't we use latest tag? I'm genuinely curious.
Yeah, so you can, that's fine, but the latest has a semantic meaning to it, which is a lie. And that's why I always say, don't use latest. So latest indicates to you that it's the latest build, right? So you have your CI and your CD. So delivery happens, and now you have an image that's built and ready for deployment. And if you tag that latest, and then I come in with another change, and I name my change by git commit or a version, semver, right? Mine's going to come, and it's newer. It has newer changes. It is no longer the latest, yet the latest tag still lingers on your image. And so what happens is you have to have an explicit step that always upgrades and moves your latest tag forward. Now, if you really want to use latest, that's the way to do it. Always migrate your latest tag to the latest build. However, since it has only a semantic or sort of a syntactic sugar thing anyway, and it can be really misunderstood, it's probably best to just not use it and only go with something like semver or git commits or something like that. Yeah. And there's another example. So Bok Joe just pointed out, roll back to the previous latest, right? It's like, well, yeah, you'd also have to make sure you do that. And if you don't do that, well, now you're really on fire, because now you've moved forward, you remembered to move your latest tag, and oh no, something's bad, let's roll back. And if you miss it, you're still pushing to prod all of your latest stuff. So
there's another,
latest is just not a great tag to use.
There's another side to the equation also, and that is when your orchestrator sees that you've, like, think through the deploy process, for example. You've built your image, you've tagged it latest, you've pushed it to your registry, which moves the latest tag to your new image. You know, so let's say that's your workflow, and then you want to go and you want to update your pod definition, or your, if you're using ECS, maybe your task definition. There's no update, right? It's not actually making any change whatsoever, because the word latest is the tag that you deployed before. The word latest is the tag that you're trying to deploy right now. And because of that, your orchestrator says, great, no change, I'm already done. And your code never goes out. Now, there are, of course, mechanisms that are available to you for overriding that. You can say always pull, no matter what, but that's kind of a waste.
Yeah, why?
Yeah, so that's, it's stuff like that that you just get to avoid all of it by not using latest. So not
and let's, and look, it's even troubleshooting. Look at the 2 a.m. rule, right? At 2 a.m., how the heck do I know what latest points to? Like, unless your semantic versioning is latest v1.0.
Shari just pointed out a solution to that, which is like, even if it's not semver, just use the hash, because the first thing I do when I see a tag, I ignore it and I just look at the hash anyway, and then I go cross look it up, and you know, so it's like you're just saving yourself headache.
Yeah, I always used to use the hash, because that for me was the one way of knowing this code is what's running in this container. And that's what ties it together. Exactly. So it was so much simpler that way. And yeah, it does mean that if you want to roll back a version, you need to be able to go and look at your previous hashes to figure out what your former hash was. But git log, like that's actually something really simple to figure out. And it's right there at your fingertips. You can figure it out in 3 seconds. So so yeah, it's definitely my favorite way to manage images. All right, let's continue on. So I think I've already done this get login password. By the way, if you're following along in, I'm scrolling on the wrong screen. If you're following along with this, just know that when you copy and paste some of these blocks, you see how when I'm highlighting, it's getting some spaces after the slash. That's going to cause a syntax error. So copy up to and including the slash, and then paste. That'll help you out. These commands all work. Don't think that that the syntax errors mean they don't work. They do, but you do have to like watch out when you're copying. And then when you're copying this, obviously grabbing this 4: is just a prompt continuation that we won't actually want to copy. So I'm gonna jump in here, and I'm just going to show for IN AMD 64 and ARM 64 do, and then we're going to Docker tag our new image, images. Done. And that way we're tagging them to be able to push to ECR. And if I then Docker, let's just verify, we should now show 4 images, two that are duplicate, 2 are duplicates of each other. So you see it's
2
the
images,
same.
4 tags. Yeah.
There you go. Yeah, thank you.
Yep.
So let's go ahead and Docker push. So again, for loop, AMD 64 and ARM 64 tags. We're going to push into ECR and done. So this is really simple. And if we want to go look at ECR, let's see, I have that here. This is the before shot. And if I refresh, you see now we have 2 images, an ARM 64 tag and an AMD 64 tag. So again, this is kind of the old style, old school way of doing this. If we wanted to deploy to different architectures using different deployment descriptions, we could. But we'd rather not. We'd rather use one deployment for everything.
Right, and just so we don't get confused as we keep going, it's not only the old school, but it's sort of like you still have to do that. It just becomes invisible for your users. So the downstream consumers of your images, because you still have to push your images.
That's true. Yes.
But we'll get to that in a minute.
Exactly.
I don't know. I don't remember writing this, so you know.
No, we will. And that is a good point. Everything that we're doing here, these are all steps that you would go and modify your build pipeline to do. So right. your users don't need to do this. Your build pipeline should do these steps. And then the users are just going, or pods or orchestrator, they're just going to do the normal thing where they Docker run. And we're going to see that here in a second. So Jesse, walk me through this Docker manifest create command while I paste it in.
So this is going to actually create the manifest. So we had said we have image manifest for all the images that we have. The manifest, we need to create one now that points to our 2 images. So yeah, as you're doing this, you can see the command will create a manifest called hello. So we'll actually have an artifact in the repository to just pull called hello, and we can tag that. And then you're identifying the images to include in that manifest.
Nice. Oh,
you created it already.
Yeah. Should I delete it or should I amend? I should probably delete it.
That's fine. You could just, I mean, you could, or you could just, we could just go on to the next step probably.
That's
right.
True. I just did that.
Cool.
Cool. All right. So the manifest is using the default latest tag here. So no big deal. What is this annotate command?
The bug says, see, it says, again, you should use something that more explicitly references. I really thought this through. This is great.
Yeah.
So so the annotate the image, or the manifest rather, so that the manifest list correctly identifies which image is for which architecture. And as you can see it's in the semantics of the command. So for this architecture, use this image. For that architecture, use that image. So,
yeah. All right. So manifest annotate done. And then if we wanted to inspect our manifest, we could. What we would see is one architecture specifying AMD 64, the other architecture specifying ARM 64. So let's Docker manifest. Do what?
I said, holy smokes, there's a whole bunch of things that came through, but I realized that was just Adam.
Just me. And
good evening, Lost Algorithm.
Good evening.
Totally.
Dennis Traub, AWS, say hey.
Welcome. So let's Docker manifest push. So this is just like, well, wait. Oh, see, I amended. I should have deleted and recreated. Let's see, Docker.
Or just used it. Yeah, that's what. I wasn't quite sure what was going to happen. So.
Well, I think I had different image IDs before.
Yeah. So just nuke it and then
Let's see. How do I delete a manifest?
Shoot, I don't remember.
Let's see here. because it's none of those commands. RM.
I think it's probably
doing it live.
Is it purge? Maybe I'm looking through the docs, to be honest.
Yeah, that's good.
Yeah, I can't remember.
I don't. No.
Somebody telling us?
Manifest. Well,
let's see. I feel like W. Shari would know.
Yeah, actually, do you have to? Is it in your registry? Like if you go back to your registry in ECR and your repository, I'm rather.
It wasn't.
Okay.
Let's see here. Let's just Google.
Yeah,
Docker.
W. Shari said no, not really. Like I don't think I've ever had to do this.
Like you could do a Docker manifest push, and then you can have a purge flag, which would delete it locally once it's pushed. But obviously,
manifest can only be deleted by digest.
You're past that. And this is officially earned the Doing It Live badge.
Amend.
I swear I've done this.
Should be that it's. Let me amend again. Maybe. Oh, this is the wrong terminal. What's the error message saying? So it's not finding the images.
Right.
SHA. So let's
Do you have to Docker login?
No, it's that it's not finding the images that are part of the manifest.
Well,
to see how this image SHA is 2ADD, and let me just get the error message back up here. It's looking for two different images, neither of which start with 2AAD. So these are, and I recognize these SHAs from earlier when I was walking through this as my image SHAs from before. Let's
can you just create a new one?
Oh, so the push, you could try the purge on the manifest push command because that says it will actually delete the local copy.
manifest push -- purge or what?
Or -p, either way.
Manifest push -- purge or -p, yeah.
Doesn't seem to do what we're wanting it to do.
Can you just go through the process again and just change the name?
Yeah, you could just do that.
Or are we just in too deep at this point?
Answer this. We should really have an answer for this, but
while we're figuring this out, a question came in from Doss Dillon. Will ECR have generic images that we could import into our ECR? So the example is an Nginx Alpine image, or would we have to build it and push it to our own ECR?
You wouldn't necessarily have to build it. You could pull it and push it to your own ECR.
Right. So there's the idea, there's a notion of a registry, which is what ECR is. And then there's the notion of a public hub or a place where you can get images, which is something like key.io or Docker Hub. And that's where you're going to find images like that. So you could, so you basically don't have to build your own Alpine image. You can pull it from someplace like Docker Hub and then push it into your, into a repository in your registry.
Yep. So short answer, pull, push. So what are we doing? Are we going to try to rebuild it?
I'm thinking this is the problem. Oh, it's running. Oh, it's running. Wait. Oh, wait. Okay. Docker PS. Let's get rid of this.
Those unruffled pikes. It's always a problem. That's the randomized name of that container, by the way. That wasn't a. That wasn't just coming up. I don't hate fish. Yeah, no, fish are good.
Okay. Let's see here. Find. What else should I prune?
Oh, that's fine. I mean, I just use a different name for now, maybe, and then.
Well, I'm gonna let's make again.
Yeah, I feel like I've hit this before, but it was different where I had pushed it to the registry, so I had to delete it from there. But
thinking through it, it may not have updated the manifest because I had a running copy. So it may not have wanted.
And so it was just stuck. You were just stuck with it.
I think that might have been what's happening. We're gonna see how far I get now.
Okay.
It's very quiet here.
I know, we should have some background music, like Jeopardy, Final Jeopardy music. The final countdown.
I am fighting an urge right now to sing the Jeopardy theme.
Okay, so we tagged Docker.
Keep fighting it.
Now we're pushing to ECR. And now we are going to manifest create.
Don't amend. I guess that's
don't amend. Yeah.
Yeah. Manifest create. Let's get rid of the amend.
Yeah. So the manifest list is still there. So so just create oh goodness, no, just create a new manifest name.
Well, at this point, I do want to see. It's still probably going to fail, but I want to see if I'm at least in the same spot I was. Yeah, I am.
Okay, yeah, because that's the same manifest. So, and I.
All right, so we can name this. You know what? It's actually not named correctly anyway, right? It should be named YAHW. Yet another hello world.
Sure.
So we created our manifest, and now when we push, well,
yeah, you're yet another hello world. Yep.
Yeah, but I need to create I need to create that registry, and then log into it. So we'll create, and we'll view push commands. Let's log in. And let's tag again. YAHW this time. Oh, whoops.
Oh, that's your image tags.
Yep.
So yeah, you could just move this whole thing over to this new repo if you want.
Oh, that's true. I could just push the manifest.
No, that's fine. You do what you're doing. That makes sense. Now you can push them. Yep.
You do you, boo.
You do you.
Yeah, doing it on the fly. Right?
Hello, that says hello still. So now make it. Yep, be perfect. You are killing this right now. This is great.
All right, let's check while we're waiting on that to happen. Yet another hello world. There's our two images. And there's the image hashes for the record. And now manifest create. And we're going to create it with yet another hello world. ARM64, yet another Hello World AMD64, and we're naming it yet another Hello World.
Yep. Wait a sec.
Well, listen,
wait a second. Wait, that's who's playing with us? What's going on?
All right.
Yeah, you got to annotate. You'd have to annotate, but I don't. But wait.
Oh yeah. No, you're right. You're right. I missed that step.
Yeah, but that won't save us. I honestly, I am not sure what's going on.
Totally worked earlier.
Of course it did. I mean, this is a brand new. Did you call it this before?
Wait a second. Am I missing the tag here? AMD 64? Is my command wrong?
Nope. No, there's art.
ARM 64, but no tag. And then.
So the annotate needs the tag for the architecture. So yeah, you're gonna need that. That should be in the blog, I think.
It is. Yeah, I'm looking at. Okay, maybe let's go back and let's grab this again. All right. So, oh yeah, but I need to add on the second line.
But it's hello here, so.
It's true. And then, just for good measure, let's change it to yet another hello world.
That looks right. So that's so what that is the manifest list and then the image for that architecture. That's that annotate command.
Manifest push. Still error.
What? Well, that was a mount error. This is very odd, everybody. So yeah, so Tommy F17, right on. Like you're
also, it's still fine. It's still looking for hello.
There's something very weird.
Instead of
I think this is going to be like, in retrospect, once we're not live, we'll be like, oh, we just fat fingered that and nobody saw it, but I can't see it. Like I don't.
And we're basically out of time.
I was like, just before we run out of time, I was just going to say these commands will work for you, I promise. And
they did.
So with ECR now, you can push this manifest list, and then wherever you are, you can just pull by the manifest list name and version, a tag of a version, so you don't have to worry about the architecture in OS anymore.
So we're going to figure out, once we drop off, we're going to figure out what's going on here, and then tomorrow we'll come back and wrap up whatever
short footnote.
It should be a short footnote, and then we'll get on to tomorrow's actual topic.
So that's a good point. So Lost Algorithm pointed out that your Docker client, your local one, will actually have a copy of the manifest in .docker.
Adam, is there a shutdown after us?
That's what I'm looking at. Just keep going.
You know what? Let's just get rid of all of it.
Yeah, you can nuke all of it.
And now
I should have thought of that. Yep. It could just be your local client that's messing with you.
I think that's all it is. Manifest annotate. And this one's YAHW this time. And then manifest push.
Well, you don't have a manifest anymore. You just have to create it quick because you just nuked everything.
We're good, Brent.
Okay. And I don't need amend. And I'm sticking with YAHW. And now I'm going to push.
Yep. Annotate.
I had annotated already. I got
You just created it though. Did you slide an annotate in there real quick in between the create and the push?
I had done an annotate here.
I don't think that one counts, but that's
Why
all
not?
right.
Why wouldn't it?
Because you just created a new one.
Here, let's
Just
see.
slide that in.
Let's see. See, I have a latest and a Shaw.
It's there. It's there.
Well, let's test it, right?
Yep.
So let's go to. Actually, we're here. This particular machine is an Intel. Let's purge or prune. Let's get rid of all of our Docker images. And now let's Docker run. And we're going to run YAHW latest, just like we said we shouldn't do.
Mm-hmm.
And it pulled an image and it's running it. So curl localhost 8080. And look.
There you go.
64, right? So let's test that out. I also have a Graviton instance in my terminal here. So this is an M5G. So let's Docker run same command, just like our orchestrator would issue. But hey,
yeah, so that's the annotate. So you could do an annotate and push, I think.
Okay. Annotate.
We're good. Keep it going, baby.
It's so painful. Not really, but I mean, you know. All right, so what should I do here? Should I just purge everything and start again?
No, you should be able to. What?
Wait, let's go back to the blog.
You should be able to annotate and push the update.
Oh, I purged all my images.
There you go.
Yeah, okay, so make all.
Yeah, that's a good point. I mean, I think we made the point where this does work, and we actually even triaged that it was just a local client issue that was plaguing us. So,
and I don't know about you, but my CI, I think everything but Jenkins, you're always in a completely fresh environment anyway. So it would be like, you know, basically impossible for this to happen in CI.
Even with Jenkins, if you can do Jenkins where you're spinning up immutable workers.
Don't defend Jenkins.
Okay, you could have immutable workers that come up to do the job and leave, or you can plug Jenkins with code build. So
those workers stay around and continue to run other jobs until
there's no jobs. They can, but don't do that. But don't do that.
I'm glad I'm between you two.
Hold me back.
All right. So now I'm going to delete my manifests again. And now I'm going to, so I've built the images.
Just reinstall the OS. Just reinstall your laptop. Just reinstall your laptop right now. It's fine, everybody. Just hang in there.
I'm going to tag everything for in Docker tag. And we're going to stick with YAHW this go around. And then I'm going to push, for push.
No, Rayduno thinks this is like triaging multi-architecture support for Docker images. Not fun.
All right, so once I've done that, I'm going to manifest create. And
this is going to create the manifest, which contains the manifest list.
Yes.
Yeah, fire away, man. And then annotate.
Annotate, and I'm not doing a min.
And that's right.
Do I have everything?
Going to tell
ARM64, YAHW. Okay, annotated.
Now, pushy.
Manifest push. Done. Just curious, because if we go look at the SHA here for latest, well, it's not showing me the SHA.
That's your, yeah.
Now I forgot what it used to say, but I think that's different. But
well, it's the stuff below that's now untagged.
Yeah, C5. Yep.
Cool. Now, if I go over here and do my Docker run command again,
Already allocated.
Already had it running. That's no big deal.
Pretend that didn't happen.
Yeah, exactly.
We are doing it live, folks.
Docker kill.
Or you could kill it, sure.
What were you gonna do?
You could just curl from the one that's running. But yeah,
that's not a fair test.
I know.
Because I had
you're a good doobie.
So yet another hello world latest. It pulled, it found something to run, and it's running. And if I curl, alrighty, let's just go grab my curl command over here. Localhost 8080. Hello.
It's done 8080.
Curl.
There you go, and that's Arch 64.
Nice.
So that's AMD architecture. I mean, of course, it wouldn't even run if it wasn't. So it did the job.
So
that might be Windows. It could be anything. Pretty cool.
We have one way to describe or in reference two different images based on whatever architecture we're running on, whatever architecture we're trying to launch, and we can put that in our pod definition or our task definition and have it just do the needful.
Bingo.
You did it. And honestly, the only problem was just a local client configuration thing. So if it's not DNS, it's going to be that. It's fine.
Exactly.
Did great.
Yes.
Nice.
It worked.
And again, all that complexity is for your build pipeline. That's for you to build images for your downstream consumers. And this allows you to then just do something like, Docker pull Golang, and you get whatever you need to, because that official image on Docker Hub is built with a manifest list.
Nice.
With all the different architectures and OS. So yeah,
cool.
Nice job.
All right. Well, thank you for joining us, Jesse. And
yes, a pleasure. It's always a pleasure.
Right on. And so for tomorrow, we're going to continue with the ECR theme, I think. I don't know what we'll look at, but we'll figure something out, aren't we?
I don't know. Yeah. We're just going to figure it out. We're going to do it.
Exactly. Watch Twitter. We'll let you know tomorrow morning what we plan to talk about. And until then, I hope everyone has a good day.
Thank you, everybody. See you soon.